Good morning. Today we are going to cover section 8.2, ellipses. Write down your title and your essential question. How do you graph equations involving ellipses? Go and paste your cutouts. We have all three cutouts at the same time. And we'll start once you are ready. Go and pause it. So the definition of an ellipse. An ellipse is the set of all points, x, y, in a plane, the sum of whose distances from two distinct fixed points is constant. And those 2 points are called the foci for plural, or one focus and then another focus. So be sure, before we get to the cutout, the definition. If you have two distinct points, and you can place the points anywhere, and notice that in this case, the sum, I can go and place it to be larger or smaller. So let's go make the sum of both segments. Let's make it 7. So that means that this segment and this segment are 7 units long. And if I collect all those points where this segment is 2.39 and this segment is 2.81 together, or 2.61 together, gives me 7. And it doesn't matter where I move it. If I add those two segments, 2 plus 4 is 6, and then that will give me 7. If I collect all of those points, then that's going to be forming an ellipse. And notice that the sum, 5 plus 1 plus 6, and then that gives me 7, will stay constant. And it has some properties. The property that it has, that if you go from this point, which is the focus, to anywhere on the ellipse and back, that's 7 units. So if you come over here and you go from the focus to the ellipse and back, that is 7 units. If we come over here, this segment plus that segment will give me 7 units. And if I continue, and if I get all those points, that is the definition that we have of the ellipse. So let's go continue with the notes, the cutout. And we have the following elements of an ellipse. Notice that we have two formulas. The first formula is if it's on the horizontal major axis. The other one is the vertical major axis. The longest side is your axis, the major axis. The other one will be your minor axis. So in this case, if the longest side is vertically, that means that it's going to be vertical major axis. And do you notice any difference between both formulas? Correct. In this case, 0 is less than b, which is less than a. That means that b has to be greater than 0 and b has to be less than a. But in this case, whenever we are graphing it, we're not going to be telling the difference between each one. And we'll go through it when we graph it. So don't worry about the difference between this formula and that formula. The numbers underneath are going to tell you which way it's facing, whether it's laying sideways or if it's standing up. One of the things I have to remember is that we have a center, we have one focus, another focus, or two foci. We have one vertex, another vertex, or two vertices, and then we have two covertices. A formula that you have to remember is that c squared is equal to a squared minus b squared, where c is the distance from the center to the vertex. And we have something called eccentricity that we're going to have to find as well. And then we're going to go over the different eccentricities for each of the conic sections and how they apply once we get to section 8.3 or 8.4. The eccentricity E is a measure of ovalness of an ellipse. How oval is the ellipse? If E is equal to C over A, know that if it's between 0 and 1, then that's going to be an ellipse. So for an ellipse, once you find the value of E, if it's between 0 and 1, then we know that's going to be an ellipse. Once you get to hyperbola, parabolas, and circles, they'll have different values for E. Example number 1. So let's go to the graphing aspect. And if you, so we just covered this in Algebra 2, so it'll be a very quick process. Go and pause it, and we'll start once you are ready. So now, I need to be able to graph the following equation. The equation is an ellipse. I'll make a graph. I'll make it 5 by 5. 2, 4, 5, 2, 4, 5. So the first thing that I need to be able to find is my center for an ellipse. If I look at my formula, my center is going to be given by H and K, just the same way that we have seen the center to be for a parabola. So therefore, my center is H and K, where H is -1, K is +2. It will be -1 and +2. Now, I'm going to be able to find my A value and my B value. Because your formula is A squared minus B squared, your A value always has to be the larger number, because we don't want the C to be an imaginary number. So therefore, under that 25 is, the square of 25 is 5, so I'll place a 5 underneath. Under the 9 is, under that Y, there's a 9. So I'll place, the square of 9 is 3. So which is the bigger number? Is 5. So therefore, that will be A. That means that B has to be 3. And now to graph it. The 5, the 25, is under the X, which is 5. The square of 25 is 5. If it's under the X, that means I'm going to have to go sideways. 5 left and 5 right. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Under the Y, there's a 9. Square of 9 is 3. Because it's under the Y, I'm going to have to go up and down. 1, 2, 3. 1, 2, 3. And now we just connect all 4 points, and we make a perfect ellipse. We collect this point. Collect this point, has to be rounded. And that is our ellipse. So in this case, our center, I'm going to label it. I need to decide which is my vertex and which is my co-vertex. The longest side is horizontally, so this one has a horizontal major axis. So therefore, your vertices will be on your major axis. So this is my vertex, and this is my other vertex. So there are 2 vertices. That means that my minor axis will contain my co-vertices, And what else do we need? So let's look at our diagram. Let's see, we have our vertices or center or vertices. So the last thing that I need to be able to find is my focus and my other focus. To find the focus, we're going to use the following. C squared. So I'm going to find the value of C. And it's not your Pythagorean theorem, it's C squared is equal to A squared minus B squared. And that is the reason that A value has to be the bigger number. So therefore, C squared is equal to 5 squared, which is 25, minus B squared, which is 9. C squared is equal to 16. So plus or minus 4, we're going to say it's just positive 4 because it's a distance. This value of C is the distance between your vertex and your focus. So 1, 2, 3, 4. That'll be my focus. 1, 2, 3, 4. And that'll be my focus. Or 2 foci. So let's see. Let's go through our cutout, and we found our center. We found our vertices or co-vertices or focus and focus or foci. The last thing that we need to be able to find is our eccentricity. We need to be able to find the value of E. And according to this, the value of E should be between 0 and 1. So the eccentricity is between 0 and 1. So find E. So your eccentricity is equal to C over A. So eccentricity is equal to C is 4 over A, which is 5. Eccentricity is equal to 0.8. Remember, your eccentricity for an ellipse has to be between 0 and 1. And we'll go over what it means. It basically means how oval it is. Is it more look like a circle or is it more flat? And we'll go over different examples during class. And my domain and range. My domain and my range. So my domain are my x values that are corresponding to the ellipse. So it'll be 2, 4, 6 from -6, including -6, because we are reaching that number, all the way up to 4, including 4. My range is from -1 all the way to 2, 4, 5. And that is the graph of an ellipse. We found all the components, we found our center, or vertices, or co-vertices, or foci. We found the eccentricity that has to be between 0 and 1. We found the domain and range. Example number 2. Go and copy it down, and we'll start once you are ready. We'll pause it. So for an ellipse, the formula that we are looking for has to be in the following form. This is the standard form, where we have a equal to 1. So therefore, I need to be able to figure out what can I do to be able to make it equal to 1. I should divide by 12. So I divide both sides by 12, or each of the terms by 12. That gives me 2. If I simplify, x minus 3 squared. So divide by 12 gives me 2, divide by 12 gives me 1. Divide by 2 gives me 1, divide by 2 gives me 6. So plus y plus 1 squared over 6 equals 1. And now we have the format that we want. Well, almost, because we don't want a leading coefficient here. So is there any way that I can rewrite this expression? Because this one's fine. I just need to be able to rewrite this expression such as the x minus 3 squared over a number that will be the same thing as 2 over 1. So what should be underneath? 2 over 1 can be written down as, correct, 1/2. Do you agree? If you take the reciprocal, you end up with 2 over 1. So now I can find my center. I can find the value of A, the value of B. And I want to make a graph. I want to just make it 5 by 5. 2, 4, 5, 2, 4, 5. So what is my center? H and K, positive 3, negative 1. Now under my x, there's a 1/2. What's the square root of 1/2? 1 over 2, take the square root. That'll be square root of 1, which is 1 over the square root of 2, which will be square root of 2 over 2. So therefore, and this will be the square root of 6, and this, let me make this in red. Remember that which is bigger, square root of 2 divided by 2 or square root of 6? Square root of 6 will be bigger, therefore that is the value of A. The value of A will always be a bigger one on an ellipse. The value of B will be the square root of 2 divided by 2. And square root of 2 divided by 2, I know the square root of 2 is 1.4, divided by 2 is 0.7. So therefore, under my x, there's a 1/2, which is the square, take the square root, that'll be square root of 2 divided by 2, which will be 0.7. Under the x, so that means I'm going to go to the left, 0.7, and under the right, 0.7. Under the y, there's a square root of 6. There's a 6. Square root of 6 is about 2.3, 2.5 is fine. So 1, 2.5. And I go up and down because it's under the y. 1, 2.5, 2.4. So therefore, if it's under the x, it goes sideways. If it's under the y, it goes up and down. And now I can make my perfect ellipse. Round it, come back, and we're set. Now I'm going to label it. You can just place abbreviate it. Notice that your bigger axis is up and down. So therefore, this one has a vertical major axis. That means that your vertices will be located here, and we can abbreviate it to place it V. This is your center. This is a co-vertex. And now I need to be able to find the value of C so I can find my foci. To find C, we're going to use C squared equal to A squared minus B squared. C squared is equal to A squared, which is the square of 6 squared, which is 6, plus B squared, which is square of 2 over 2 squared, which is 1/2. C squared is equal to 6.5. And the square of 6.5, C is approximately. And we can use a calculator or you can estimate it. Either one is fine. Usually on the test, I'll be giving you guys whole numbers, so you won't need a calculator. So we have the square root of 6.5. That will give you 2.54. So notice that in this case, what's the square of 6? And I already made a mistake. Can you just catch my mistake? What did I do? So one of the things that I noticed is that, well, my square of 6 is 2.4. So that's 2.4. My focus has to be inside. So if this is 2.54, that means that's going to be outside. Yes, that should be a minus. So therefore, let me go and fix that. That should be minus 5.5, and that should be a different number. Therefore, that'll be the square root of 5.5, which is just a bit smaller, which is 2.34. So 2.3. 1, 2.3. That'll be your focus. 1, 2.3, and that'll be your focus. The last thing I need to do is find my domain and range and my eccentricity. Let's go and find E. Remember, the value of E for an ellipse should be between 0 and 1. So therefore, E equal to C over A. E equal to C, which is 2.3, or the square root of 5.5. And we're going to actually just leave it as a decimal. Let's go and just place 2.3 over A, which is the square root of 6. And the square root of 6 is 2.4. So therefore, I'm now going to place my fraction, and I'll place it as a 5.5 divided by the square root of 6, which should be between 0 and 1, which is 0.96. So E is about 0.96. So notice that the closer that it gets to 1, the more of a skinny slit or narrow ellipse will be. The closer it gets to 0, that means that's going to be more of a circle. But we'll talk about that on section 8.4. Last is my domain and my range. Let's go and place my domain here and my range here. So my domain, from where to where does it go? It starts here. So we're going to base ourselves to be able to get an exact domain. We're going to base ourselves from the center. So I note that to get from here, this is 3. And I'm going to subtract this distance. And we know that this distance is the square root of 2 over 2, correct? So therefore, it'll be from 3 minus the square root of 2 over 2 all the way to this point, which will be 3 plus square root of 2 over 2. And that is my domain. Because we do want to be able to have an exact answer for the domain, we are going to place from our center. And this distance was square root of 2 over 2, so we're going to subtract. And then from our center, we're going to add it. And that gives us our domain. If we want to be able to find an estimate, we can do 3 minus the square root of 2 divided by 2. That should give you about 2 point something. And if I want to find this point, I can do 3 plus the square root of 2 over 2. And that'll be 3.7. But this will be the exact domain. For my range, we're going to do the same thing. For my range, it's going to be the lowest value is this point vertex. So that'll be from -1 minus the square root of 6, because that's how far we came down, minus the square root of 6, all the way to this point here, which was -1 plus the square of 6. And including those two values. So that is your domain and range. And we will be doing that every time those are not exact values. We want to make sure that you give your domain and range on exact values if it's possible. And we know that that's possible based on these two values. Example number 3. Go and copy it down and we'll start once you are ready. Go and pause it. So find the standard equation of an ellipse having foci of -2 and 2 and 4 and 2 and the major axis of length of 10. Now when you encounter this type of problem, it is best to sketch a graph, and that's going to make your life much easier. And I'm going to plot the information that's provided for me. Well, my foci is -2 and 2. So -2 and up 2. I'm going to label it. 4 and 2. So therefore, according to this two foci, the ellipse should be sideways, correct? It should be laying down. Now, the major axis is 10. So let's see, can we find the center? If this is one focus and this is another focus, we know the center should be in the middle. So it'll be 1, 2, should be here. So therefore, we can deduct that this is my center, which is my center is 1, 2. So therefore, I can start shaping my ellipse. Will be x minus h plus y minus k equals 1. So therefore, I just need to be able to find those two values. They do tell me that the major axis is 10. That means from one side to another should be 10. So that means that from my center should be 5 to the right and 5 to the left. So therefore, those are my vertices. And because for my center, I went sideways, 5. That means under my x will be 5 squared, which is 25. That means that my a value is 5 because that is the longest side. So the only thing I need to be able to find is my b value. And how can I find my b value? Correct. We can use the formula. So I'm going to find b. It'll be a squared, so c squared equals a squared minus b squared. And what's the value of c? Well, c is the distance from your center to your focus. So therefore, it'll be 1, 2, 3. 3 squared is 9. So therefore, c equals 3. A is the distance from your center to your vertex, which is 1, 2, 3, 4, 5. And let me go and label it so we can actually have some reference. This is 1, 2, 3. And we know that this is 5 is my distance from my center. 1, 2, 3, 4, 5. So therefore, that is where we got the 5. And now, 5 squared is 25. Or what's 5 squared? Minus 25 on both sides, so therefore, or move my b to the left because positive b squared. 25 minus 9 is 16, so therefore b equals 4. No, that's not correct. Is it correct? That's not. questions. So that'll be 4, but here will be correct. This is 4, and this is b squared, which is 16. And that is the equation. That means that from here, I'm going to go up 2, 4, and 2, 4 to be able to finish my ellipse. But it is important that you sketch the information that's given to you. In this case, we need to be able to find b. We found b, but be able to find the distance between the center and the focus, that is c. And the last example for today. I need to be able to rewrite it in standard form. So I need to be able to rewrite it, the following equation, into this form here. So we're going to go through the process of completing the square. First, you're going to group your x's together. Then we're going to group your y's together. And we're going to move the number to the other side. And we're going to leave some space so we can complete the square. 9x squared minus 54x. Leave some space. And add the y's. 4y squared plus 40y. Leave some space so we can complete the square. And now we can move the 37 to the other side, becomes a negative 37. Many students forget to change the sign, or you can do minus 37 on both sides. Now to complete the square, we remember that we cannot have a leading coefficient. So I'm going to factor out the 9. And what's left behind? 9 times x squared and 9 times negative 6x. I need to complete the square. I'm going to do the same thing on the other side. I'm going to factor out a 4. And what's left behind? Y squared plus 10y. And now we can complete the square. What I add on one side, I need to do to the other side. That's for the first one. And this is for the second one. And what number goes in here? Remember, your formula for completing the square is b divided by 2, and then we square it. What's half of negative 6? Negative 3. Square is positive 9. And what I do on one side, I need to do to the other side, but I'm not adding 9, because this 9 is being multiplied by the 9, so therefore that should be a 81. And what's on one side, it needs to be to the other side. So we actually are adding 81. Now most students just place that 81 here, but I want to make sure that you understand that that is what we are adding to one side, and we need to add the same to the other side. However, for this one, half of negative of 10 is positive 5. Square gives me positive 25. And what I add on one side, what should go here? Correct. It should be 4 times 25, which is 100. That's 181 minus 37. That is 4. That is 4, and that's 1. So 144. So therefore, I'm going to factor this out. This will be equal to 144, all three numbers. I'm going to factor this out, so it'll be 9. We know that this is x and x. Positive 3, no, negative 3, negative 3. Nine x minus 3 squared plus 4. And this will be y and y. Factors of 25 will be 5 and 5, and they both should be positives. Or 4 and y plus 5. There's 2 of them, so we can rewrite them as 1. Once again, we want to make sure that it's equal to 1. So what should I do? I should divide by 144. 9 divided by 144, 1 into 90 goes 10, 54 is 6, so it'll be 16. So therefore it'll be x minus 3 squared over 16. That'll be 30 and 24, so it'll be 36. So now if I want to be able to graph it, my center is 3 and negative 5. Under the x, there's a 16, so I'm going to go to the left 4 to the right 4. Under the y, there's a 36, so I'm going to go up 6 and down 6. And then I can shape my ellipse. So that's the lesson for today. Have a good day, and I'll see you next time.